We will now continue with our study of radical expressions by learning how to simplify radical expressions. Now, I told you all the skills that we learned in the last lesson are going to be used in simplifying radical expressions. Now, the first rule we are going to use in simplifying radical expressions is the product rule. What is the product rule for radicals? Now, the product rule for radicals can be written as square root of a times b equal to square root a times square root b. A simple rule. Now, for example, 36 can be written as 9 times 4. So, square root of 36 is the same as square root of 9 times 4. We can now use the product rule here. Can you use the product rule and tell me how to write it? Look at the product rule. Square root of a times b is square root of a times square root of b. So square root of 9 times 4 is square root of 9 times square root of 4. Alright, what is square root 9? Square root 9 is 3. What is square root 4? Is 2. 3 times 2 is 6. And isn't square root 36 equal to 6? Yes. So product rule is a very useful tool, and we will be using it continuously to simplify radical expressions. In other words, if I have something like this, square root of 16 times 3, I can write it as square root 16 times square root 3. You see, it's very useful because it is a very useful way of simplifying. Square root of 16 times 3 is square root 16 times square root 3. Why is it useful? Because square root 16 is 4. So I can now write it as 4 times square root 3. And 4 times square root 3, you write it as 4 square root 3. Okay, let's use this now to simplify radical expression. Now, before we start using the rule, we must understand certain fundamental principles. Any number that can be written in the form a squared is a perfect square. What does that mean? Well, 4 can be written as 2 squared. That means 4 is a perfect square. 9 is a perfect square, and so on. So 4 equal to 2 squared is a perfect square. 9 equal to 3 squared is a perfect square. 121 equal to 11 squared is a perfect square. 196, this is the third time we are meeting this number. 196 is 14 squared. It is a perfect square. Now, can you give me some more examples of perfect square numbers? You see, let's go through the table of perfect square numbers. What are the perfect square numbers? 4 is a perfect square. 9 is a perfect square. What is the next perfect square? 16. What is the next perfect square? 25. What is the next perfect square? 36. 49. 64. 81. 100. 121. 144. 169. 196. You see, look at the way we can write all perfect square. Now, what is the advantage of identifying perfect squares? You see, 196 is a perfect square. What is square root of 196? Square root of 196 is 14. What is square root of 121? Is 11. What is square root of 9? It is 3. What is square root of 4? That is 2. So, square root of a perfect square is a whole number. Square root of 196 is, oh, there it is. What is square root of 225? 15. What is square root of 400? It's 20. What is square root of 64? 8. So, square root of a perfect square is always a whole number. So, it's nice to be familiar with them. In the same way, what are perfect cubes? Perfect cubes. Now, 2 times 2 times 2, 2 cube equal to 8 is a perfect cube. 3 times 3 times 3 is 27. 27 is a perfect cube. 4 times 4 times 4 is 64. 64 is a perfect cube. 5 times 5 times 5 is 125, is a perfect cube. You see? So, 8 equal to 2 cube is a perfect cube. 27 equal to 3 cube is a perfect cube. 64 equal to 4 cube is a perfect cube. 125 equal to 5 cube is a perfect cube. Now, why is it important to know your perfect cubes? Because if you want to find the cube root of these numbers, it is now simple. Tell me, what is cube root of 8? Cube root of 8 is 2. Cube root of 27 is 3. Cube root of 64 is 4. Cube root of 125 is 5. So, if you have your perfect cubes, it is easier to find their cube roots. And in order to simplify radical expressions, you must be familiar with these perfect cubes. So you must know your perfect squares, your perfect cubes, and so on. In the same way, a number that can be written in the form a to the power 4 is a perfect fourth power. Can you give me at least 2 examples of a perfect fourth power? Look at this. 2 times 2 times 2 times 2. What is that number? It's 16. 2 to the power 4 is 16. 16 is a perfect fourth power. 3 times 3 times 3 times 3. What is that number? 3 raised to the power 4 is 81. 81 is a perfect fourth power. So 16 is a perfect fourth power. 81 is a perfect fourth power, and so on. Now, why do we need perfect squares? Because it is easy to obtain the square root of a perfect square. Square root of a squared equal to a. Square root of 11 squared equal to 11. Square root of 5 to the power 6. Now, you must learn this technique. Now, 5 to the power of 6 can be written as 5 to the power of 3 raised to the power of 2. So, square root of 5 to the power of 6 is 5 to the power of 3. Now watch this. I'm going to show you a very easy way to find the square root of a number written in the exponent form. Alright? Okay. Now, what is square root of 5 to the power 6? Now, You know that you just found square root of 5 to the power of 6 is 5 to the power of 3. Now how did you get that 3? What all you need to do is divide the power by 2. Why the 2? Square root. Actually there must be a number there. For square root we don't write it. You see, the type of radical, this is a 2, second root. Square root is the second root. So if you want to take the square root of 5 to the power of 6, what all you need to do is divide the power by 2. So that will be 5 to the power of 6 divided by 2, that is 5 to the power of 3. So square root of 5 to the power of 6 is 5 to the power of 6 divided by 2, which is 5 to the power of 3. Tell me, what is square root of x to the power of 10? Can you do it the same way? Square root of x to the power of 10 is x to the power of 10 divided by 2. So that will be x to the power of 10 divided by 2, that is x to the power of 5. Tell me, what is cube root of x to the power of 9? Well, we can do this the same way. Here, the type of radical is the third root. So, to find the cube root of x to the power of 9, simply divide this power 9 by 3. So that will be x to the power 9 divided by 3, that is x to the power of 3. Alright, tell me, what is square root of p to the power of 20? P to the power of 20. You can now tell me. Square root of p to the power of 20 will be p to the power of 20 divided by 2, that is 10. So that will be p to the power of 10. Alright, just one more question. What is cube root of x to the power of well, 6? What is cube root of x to the power of 6? That will be x to the power of 6 divided by 3. That is x squared. Now, what that tells you is this. If a power is even, like 5 to the power of 6, 5x to the power of 10, p to the power of 20, if the power is even, then that is a perfect square. This is a perfect square. This is a perfect square. This is a perfect square. If the power is even, then that number is a perfect square. Now, when will a power becomes a perfect cube? A power becomes a perfect cube if the power can be divided by 3. This is a power 9. 9 can be divided by 3. This is a perfect cube. Cube root of x to the power of 9 is x cubed. Cube root of x to the power of 6 is x squared. So this is a perfect cube. Alright, keep this in mind. What makes an exponent a perfect square or a perfect cube? Let's move on and look at more examples. So, we have gone through this. To find the square root of a number with an exponent, what do? Just divide the exponent by 2. Square root of 5 to the power of 6 is 5 to the power of 6 over 2, that is 5 cubed. Square root of 2 to the power of 12 is square root of 2 to the power of 12 divided by 2, that is 2 to the power of 6. to find the square root of a number with an exponent, divide the exponent by 2. That means if the exponent is even, then that number is a perfect square. What is square root of x to the power of 8? Square root of x to the power of 8 is x to the power of 4. Square root of a to the power of 20 is a to the power of 20 divided by 2. That is a to the power of 10. So once again, if you want to find the square root of a number raised to an exponent, what all you need to do is divide that exponent by 2. Similarly, to obtain the square root of a perfect cube, what do? Divide the exponent by 3. So cube root of a cube is a. 3 divided by 3 is 1. A to the power of 1. Cube root of 4 cube is 4. Or I can say cube root of 2 to the power of 12. Can you tell me what that is? Cube root of 2 to the power of 12 is 2 to the power of 12 divided by 3. That is 2 to the power of 4. Alright, you must be very thorough with this. To find the cube root of a number with an exponent, simply divide that exponent by 3. To find the cube root of a number with an exponent, divide the exponent by 3. Cube root of 2 to the power of 9 is 2 to the power of 9 divided by 3. That will be 2 to the power of 3. Cube root of x to the power of 12 is x to the power of 12 divided by 3. That is x to the power of 4. Cube root of a to the power of 21 is a to the power of 21 divided by 3. That is a to the power of 7. So how do you know if an exponent is a perfect cube? If an expression is a perfect cube, then the exponent can be divided by 3. 2 to the power of 9 is a perfect cube. You can find its cube root. X to the power of 12 is a perfect cube. You can find its cube root. A to the power of 21 is a perfect cube. Why? Because the exponent can be divided by 3. Okay. Keep that in mind. We were going to use that very, very soon. Now tell me, what is the value of fifth root of 2 to the power of 10? Can you now extrapolate it and use those results here? Fifth root of 2 to the power of 10. To find the value here, what all you need to do is divide that exponent 10 by this radical number 5. So that will be 2 to the power 10 divided by 5. That is 2 raised to the power of 2. Okay? Let's move on. We will use the following steps to simplify a radical expression. I want you to pay attention here and learn it well. Very often students find it difficult. But it is difficult because you don't understand the basics. So pay attention. I'm going to show you the steps that you need to go through. Step 1. Write each factor inside the radical as the product of the largest perfect power of the radical. In other words, if you have a number, for example, you want to find square root of 24. You see, what you need to do is write that 24 as the product of a perfect square and another number. Now, 24 can be written as 12 times 2, but that is no good for us because 12 is not a perfect square, 2 is not a perfect square. Alright, 24 can also be written as 8 times 3. 8 is not a perfect square, 3 is not a perfect square. So that's not useful. 24 can be written as 4 times 6. You see, 4 is a perfect square. So when you want to simplify a radical expression like this, write this as the product of two numbers such that one of them is the highest possible perfect square. Now what is the highest possible perfect square in 24? The highest possible perfect square in 24 is 4. So 24 can be written as 4 times 6. And now, your next step, before I write down the steps, let me talk about it. Your next step is use the product rule to split this into two radicals. You remember the product rule? Square root of a times b is square root a times square root b. Square root of 4 times 6 is square root 4 times square root 6. There you are. So that will be square root 4 times square root 6. Why do we write it like this? Because square root 4 can be simplified. Square root 4 is 2. So the answer here will be 2 square root of 6. Now this is the method that we're going to use. So what is the first step? Write each factor inside the radical as the product of the largest perfect square or perfect power for that radical. What does that mean? If it is a square root, you identify the largest perfect square. If it is a cube root, you identify the perfect third power. Is that right? And so on. Alright. Example, you want to now find the cube root of 54. Look at this. What is the largest perfect cube? You see the cube root. So you must look for the perfect cube. 27 times 2 is 54. And isn't 27 a perfect cube? Yes. So look at the way we wrote. Cube root of 54 is cube root of 27 times 2. That is the first step. 27 is the perfect cube. Look at this now. If I want to write square root of 32 times x to the 5, can you write 32 as the product of a perfect square and another number? 32 is 16 times 2. You must be able to identify. 16 is the largest perfect square in 32. So we wrote 32 as 16 times 2. Now look at this. X to the power of 5. Is x to the power of 5 a perfect square? No. A number with an exponent becomes a perfect square if the exponent is an even number. So, look at the way I'm going to write x to the power of 5. X to the power of 5 is written as x to the power of 4 times x. X to the power of 4 is a perfect square. So, first thing I did, I wrote 32 as the product of 16 and 2. Why? 16 is the largest perfect square in 32. Then I wrote x to the power of 5 as x to the power of 4 times x. You see, an exponent becomes a perfect square when the exponent is an even number. So x to the power of 4 is the largest perfect square in x to the power of 5. Always look for the largest one. So this is what is meant by the first step. Write each factor as the product of a perfect power for that radical. This is the square root, so this must be a perfect square. In this case, this is a cube root, so you must look for perfect cube. That is what the first step means. Alright, 16 and x to the power of 4 are perfect squares. What is the second step? Second step, use the product rule to write the expression as the product of radicals. In other words, separate the radicals into several pieces. For example, here you have cube root of 27 times 2. Separate that into two radicals. It will be cube root of 27 times cube root of 3. Why is that important? Cube root of 27 can be evaluated. What is cube root of 27? Cube root of 27 is 3. So this can be easily simplified. And look at this one, which we did in the earlier slide. Square root of 16 times 2 times x to the power of 4 times x. There are 4 different terms in there. I can write each of them under separate radicals using that product rule. That will be square root 16 times square root, well, you see, if you notice, let's identify the perfect squares first. 16 is a perfect square, so I wrote square root 16. X to the power of 4 is a perfect square, is that right? So we write that as square root x to the 4. Now 2 is not a perfect square, x is not a perfect square. We're going to leave them together under one radical. So once again, take each of the perfect squares and put them under separate radicals, and all the remaining ones leave them under one radical. So that will be square root 16 times square root of x to the 4. They are both perfect squares, and the remaining 2 and x will remain under radical. Now, this can be now simplified because you know what square root 16 is. What is square root 16? That is 4. What is square root of x to the power of 4? Is x to the power of 2. But can you simplify this any further? No, this will remain inside the radical. Okay. Step 3, simplify the radicals containing the perfect powers. So, if you simplify this now, or if you come to here, square root 16 times square root x to the 4. Square root 16 is 4. Square root x to the 4 is x squared. And this will remain as it is. You can see the simplified result therefore is 4x squared times square root of 2x. Now what will be the simplified form of this? Cube root 27 is 3. So this will be 3 cube root of 2. Okay, so follow these 3 steps. Do you want me to say that those 3 steps once again? What is the first step? The first step is, inside the given radical, write each number as the product of a perfect power and another number. And then use the product rule to separate them into individual radicals. And then simplify. Okay, let's practice this. Simplify square root 24. I have actually done that for you. Alright? We write 24 as the product of a perfect square. How do you know we need the perfect square? Because we need to simplify the square root. So write 24 as the product containing the largest perfect square. Tell me, what is the largest perfect square in 24? We said that already. Is 4. 4 is the largest perfect square in 24. So how do we write 24? We write as 4 times 6. Therefore, square root of 24 is written as square root of 4 times 6. And now what is the next step? We have now written it with a perfect square and the product of a perfect square and another number. Your next step is separate this into two radicals. Write this as the product of two radicals using the product rule. That will be square root of 4 times square root of 6. Separate into individual radicals. Well, now you know how to simplify this. Simplify the perfect square radical. This is the perfect square radical. Square root 4 is 2. And you cannot do anything with square root 6. So we leave it as it is. The answer therefore is 2 square root of 6. This means 2 times square root of 6. Another one. Simplify square root 18. Square root 18. It's a square root, therefore you look for perfect squares. Tell me, what is the largest perfect square in 18? If you know your number, alright, work through your mind. 18 is 9 times 2. 9 is the largest perfect square in 18. 9 is the largest perfect square in 18. That means 18 can be written as 9 times 2. Therefore, square root 18 is square root of 9 times 2. What is the next step? Separate that into two radicals by using the product rule. So that will be square root 9 times square root 2. And now simplify the perfect square radical. This is the perfect square radical. Square root 9 is 3. So that will be 3 times square root 2, or 3 square root 2. Okay, I hope you're getting the hang of this. Let's do another one. You must look for the type of radical. Simplify cube root of 24. This time you are simplifying a cube root. That means you must be looking for perfect cubes. Tell me, what is the largest perfect cube in 24? Well, you must be familiar with your perfect cubes. 8 is a perfect cube. The next perfect cube is 27. The next perfect cube is 64. You see? Now, is there a perfect cube in number 24? Yes. 24 is 8 times 3. So, there is a perfect cube in there. Now, 8 is the largest perfect cube in 24. 24 is 8 times 3. Therefore, cube root of 24 is cube root of 8 times 3. What's the next step? Separate that into two radicals. That will be cube root of 8 times cube root of 3. Tell me, what is cube root of 8? You can simplify this. Cube root of 8 is 2, because 8 is 2 cube. Cube root of 2 cube is 2. So the answer is 2 times cube root of 3. Now take care, when you multiply a number, distinguish this number with this number which is written inside that sign. So this number tells you the type of radical, cube root. Don't confuse it with this number. This is 2 times cube root of 3 or 2 cube root of 3. That is the simplified form of cube root 24. Let's simplify cube root of 81. You see how important it is for you to know your number. Is there a perfect cube in 81? Can 81 be written as a perfect cube number times another number? Again, to do that, you must flip through your mind. What are your perfect cubes? 2 cube is 8. 8 is the first perfect cube. 3 cube is 27. Is that right? Now, you know 27 times 3 is 81. So, 81 contains a perfect cube. The largest perfect cube in 81 is 27. 27 is the largest perfect cube in 81. So we can write 81 equal to 27 times 3. And so, cube root of 81 can be written as cube root of 27 times 3. And now split that into 2 radicals. Alright, write this as the product of 2 radicals. That will be cube root 27 times cube root 3. Why did we write like this? Because cube root 27 is a whole number. What is cube root 27? 27 is 3 cube. Cube root of 3 cube is 3. So that will be 3 times cube root of 3. 3 times cube root of 3, or we simply read it as 3 cube root 3. Just like we said 3x, 3 cube root 3. Okay, another one. Simplify 4th root of b to the power of 23. Let's see how many of you can get that. 4th root of b to the power of 23. Now the type of root is the 4th root. Therefore, we are looking for perfect 4th power. A perfect 4th power will have an exponent which can be divided by 4. Now, can you give me some exponents? See, for example, b to the power of 4 is a perfect 4th power. B to the power of 8 is a perfect 4th power. B to the power of 12 is a perfect 4th power. B to the power of 16 is a perfect 4th power. B to the power of 20 is a perfect 4th power. Because all these powers can be divided by 4. Is b to the power of 23 a perfect 4th power? No. So, we need to write this b to the power of 23 as the product of 2 exponents. Can you write that? If you know your product rule. B to the power of 23. Let me show you here. Can I write it like this? B to the power of 23 is b to the power of 20 multiplied by b to the power of 3. Do you agree with me? If you go back to your old product rule for exponents, what is b to the power of 20 times b to the power of 3? It is b to the power of 20 plus 3 is 23. You see? So b to the power of 23 can be written as b to the power of 20. This is a perfect 4th power times b to the power of 3. you must take the largest perfect fourth power. Alright, let's deal with this now. We write b to the power of 23 as the product containing the largest fourth power. And remember, a fourth power radical, a fourth power exponent is divisible by 4. Therefore, b to the power of 20 is the largest fourth power in b to the power of 23. Right? Okay. That means we write b to the power of 23 equal to b to the power of 20 times b to the power of 3. So, we will now say fourth root of b to the power of 3 is fourth root of b to the power of 20 times b to the power of 3. Are you following me here? Okay. Now, what's the next step? Separate that into two radicals. Now, that will be fourth root of b to the power of 20 times fourth root of b cubed. Why did we do that? This is a perfect fourth power, which means you can now take the fourth root of this. What do? Divide the power by 4. There you are. So, this will be b to the power of 20 divided by 4 times fourth root of b cubed. This cannot be simplified any further. That's going to stay like that. But this is now b to the power of 5. So our answer is b to the power of 5 times fourth root of b cubed. Okay? Alright, take note of this. We are going to use this in many of our coming examples. And look at this. Simplify square root 75 a to the power of 7 b to the power of 11. This is a square root. So what kind of perfect power are we looking for? We are looking for perfect squares. Alright. You need to write this 75 as the product of the highest perfect square. Can you think of 75 as the product of a perfect square times another number? Does it come to your mind? Alright, can I help you? Yes? 75 is 25 times 3. Isn't 25 a perfect square? Yes. Okay, in that case you can help me with this. A to the power of 7 is not a perfect square. Why? Because the exponent is odd. A perfect square will have an even exponent. Alright, can you help me write this? A to the power of 7 as the product of a perfect square and something else. Yes? That will be a to the power of 6 multiplied by a to the power of 1. A to the power of 6 is a perfect square. Similarly, b to the power of 11 can be written as b to the power of 10, that's a perfect square, times b to the power of 1. Alright? Write each number inside the radical as the product of perfect square. Now, how do you know we need the perfect square? Because this is a square root. Alright, 75 is 25 times 3. We talked about it. A to the power of 7 is a to the power of 6 times a. No problem there. B to the power of 11 is b to the power of 10 times b. And look at that. All the perfect squares I have used red. 25 is a perfect square. A to the 6 is a perfect square. B to the 10 is a perfect square. And the other factors that are not perfect square, I used blue. And now let's put it all together inside the radical. And Therefore, square root of 75, a to the power of 7, b to the power of 11. 75 is written as 25 times 3. A to the power of 7 we wrote as a to the power of 6 times a. B to the power of 11 we wrote as b to the power of 10 times b. And watch again my colors. The perfect squares are colored red and the others are blue. Now, what are the ones that are going to get separated out? Are the perfect squares. Now watch this now. The perfect squares are separated out into separate radicals. That would be square root 25. Look at all the red ones. Take the 25 out and write it as a separate radical. Square root 25, square root a to the 6th times square root b to the 10. We have separated all the perfect square radicals. And then keep all the remaining inside one radical. Square root of 3ab. There you are. Why? Because all these perfect square radicals can be simplified. This cannot be. Its fate is to stay inside that square root forever. Alright, square root 25 is 5. Square root a to the power of 6 is a to the power of 3. You understand that? 6 divided by 2 is 3. Square root b to the power of 10 is b to the power of 5. So these three terms get simplified as 5a cubed b to the power of 5. And this will remain as it is, square root 3ab. Now look at the beautiful way we have come up with that simplest form. Okay? I hope you can practice these kind of things now on your own. Try this one more time on your own. Another one. Cube root. This time look at the type of root. Cube root of 16x cubed y to the power 6. Now this time we are not looking for perfect squares. This time we are looking for perfect cubes. Alright? Can you give me 16 as the product of, is it possible that 16 can be written as a perfect cube multiplied by something? Well, if you know your perfect cube, 8 is the perfect cube. And 16 is 8 times 2. Okay, how about x cubed? Can you recognize x cubed as a perfect cube? Yes, because that exponent 3 can be divided by 3. X cubed is a perfect cube. How about y to the power 6? It is also a perfect cube. Why? Because the exponent 6 can be divided by 3. Okay, let's write that down. Now this is the first step that we do always. Write each number inside the radical as the product of the highest perfect cube this time. Because we are looking for the cube root, we must look for the perfect cube. Alright, 16 is 8 times 3. 8 is a perfect cube. Alright, x cubed and y to the 6th are perfect cubes. So you don't need to do anything to them. They are, by their own rights, they are perfect cube. So we can now write cube root of 16 x cubed y to the 6th equal to. Cube root of 16 is written as 8 times 2. X cubed and y cubed is left alone. And you can see again, the red coloring are perfect cubes. We can separate them out. That will be cube root of 8 times cube root of x cubed times cube root of y to the power of 6. Is that right? Each of the perfect cubes we can take out in a separate radical. and what remains inside the last radical will be that blue 2. Where I use blue is the leftover, so that will be on its own. Alright, simplify this. What is cube root of 8? Cube root 8 is 2. Cube root of x cube. To find the cube root of a power, simply divide the exponent by 3. Cube root of x cube is x. Cube root of y to the power of 6 is y to the power of 6 divided by 3, that is y squared, times cube root of 2. And so that is our answer for simplifying this. Okay, let's move on to another one. Simplify 20 square root. This time it is a square root. Now, when you're simplifying a square root, you will be looking for perfect squares. Alright? 24, we have already done this, is 4 times 6. 4 is the highest perfect square in 24. How about x to the power of 15? What is the highest perfect square in x to the power of 15? It should be x to the power of 14. You see, even number. The next highest from 15 is 14. So x to the power of 15 is x to the power of 14 times x. X to the power of 14 is a perfect square. And y to the power of 20 is a perfect square. We don't need to do anything to that. How about z to the power of 27? Can you write that as the product of a perfect square? What is the highest perfect square in z to the power of 27? I want to see some of you whispering. Yes, that will be z to the power of 26. That's right. Z to the power of 27 is z to the power of 26, the highest perfect square, times z. Alright, let's now use all these inside the radical. 24 is written as 4 times 6. X to the power of 15 became x to the power of 14 times x. Y to the power of 20 is itself a perfect square. Z to the power of 27 is written as z to the 26 times z. And how many perfect squares are there? 4 is a perfect square. X to the power of 14 is a perfect square. Y to the power of 20 is a perfect square. Z to the power of 26 is a perfect square. We will take them all out and leave them all in separate radicals. And that will be square root of 4 times square root of x to the 14 times square root of y to the 20 times square root of z to the 26. And what are the remaining terms? The remaining are 6xz. We will group them all together and leave it under one radical. And now simplify each of these. Square root 4 is 2. Tell me, what is square root of x to the power of 14? Well, to find the square root of an exponent, simply divide the power by 2. Square root of x to the 14 is x to the power of 7. Square root of y to the power of 20 is y to the power of 10. And square root of z to the power of 26 is z to the power of 13. Alright, so that will be 2, x to the power of 7, y to the power of 10, z to the power of 23, and this will remain as it is, square root 6xz. This is the simplified form of this radical expression. I hope by now you are familiar with this method and feel comfortable with it. Okay, let's try another problem. Simplify square root of 75 over 3. You see, in this case, it's a very simple one. If you understand your number, you know 75 can be divided by 3. What is 75 divided by 3? 75 divided by 3 is 25. And 25 is a perfect square. Square root 25 is 5. Isn't that simple? Yes. So this can be simplified as 75 I wrote as 3 times 25. And the 3 and the 3 goes. So that will be square root of 25 equal to 5. Such a very simple one. Let's look at another one. Simplify square root of 81 divided by 100. Tell me what property you have learned so far is going to be used here. Do you remember we talked about square root of a over b equal to square root a divided by square root b? We will use that property here. This can be written as square root of 81 over 100 is square root 81 divided by square root 100. Why did we choose this way? Because we know 81 is a perfect square, 100 also is a perfect square. So square root 81 is square root of 9 squared. Square root of 100 is square root of 10 squared. Well, that will be 9 over 10. Very simple. Let's look at another one. Simplify cube root of 64 divided by cube root of 8. Now, this is the opposite. Square root a times square root b can be written as square root of a over b. Let's do that. You can write this as cube root 64 divided by cube root 8 is cube root of 64 divided by 8. Look at the advantage there. What is 64 divided by 8? 64 is 8 times 8. And so the 1 8 and the 8 goes. You got cube root of 8. And what is cube root of 8? It's a 2. You see how simple that is. Okay. Well, simplifying radical expressions is an important skill. Alright? And we have done large number of these problems. I want you to now go to your homework and practice this with as many examples as possible. Now, do some problems you can repeat a couple of times so that you feel comfortable. Now, make sure that you understand the underlying principles. Alright? Okay. I will get back to you with the next lesson on radicals. Remember, the theme of Unit 6 is all radicals. Simplifying radical expressions. Alright, I will see you for another lesson on radicals later on. Change